Long before Johannes Gutenberg was even a twinkle in his father's eye, the story of printing began far away in Asia. It wasn't about big machines or clanking metal just yet. It started with something much simpler, a stamp. Think of the seals used by ancient kings in Mesopotamia or China thousands of years ago. These little carved objects, pressed into wet clay or wax, were a way to leave a mark, a signature, a sign of authority. This was the absolute basic idea of printing, taking a pattern and making a copy of it. You carve something once, and you can stamp it 1,000 times. It's a brilliantly simple concept, and it was the first tiny step on a very long journey. The next giant leap forward was the invention of paper in China around the 2nd century AD. Before paper, people wrote on all sorts of things: heavy bamboo strips, expensive silk, or cumbersome clay tablets. Paper, made from mashed up plant fibers, was a game changer. It was light, it was cheap to make, and it was brilliant at soaking up ink without smudging. Suddenly, you had the perfect surface for writing, and crucially, for printing. With both ink and paper ready, the stage was set for the next big invention, which would allow people to copy not just a small seal, but entire pages of text and pictures. This invention was woodblock printing, which became popular in China during the Tang dynasty around the 7th century. Imagine you wanted to copy a page from a sacred text. You would take a flat block of wood and painstakingly carve away everything that wasn't a word or an image. The characters and pictures were left raised up. Then, you'd brush ink over the block and press a sheet of paper onto it. Peel it off and voila, you have a perfect copy. The oldest known printed book in the world, the Diamond Sutra from 868 AD, was made this way. It was an incredible technology, allowing for the mass production of calendars, religious texts, and government notices. But woodblock printing had one major drawback. Carving a whole page took ages, and once you'd carved it, you couldn't change a single letter. If you spotted a mistake, you had to carve the entire block all over again. This led a clever man named Bi Sheng in China around 1040 AD to come up with an even better idea: movable type. He made individual characters out of baked clay. You could arrange them to make your words, print your page, and then break them all up to be used again for a completely different page. This was revolutionary. Later, in Korea during the Goryeo dynasty, they perfected this idea by casting the type in metal, making it far more durable. The Korean Jikji, printed in 1377, is the oldest surviving book printed with metal movable type. Now, let's fast forward a few hundred years and travel west to Mainz, Germany, in the mid-15th century. This is where we meet our main character, Johannes Gutenberg. He was a goldsmith and a businessman, a man who knew a lot about working with metal and was always looking for a good idea to make some money. At the time in Europe, books were incredibly rare and expensive. They were all copied by hand, usually by monks in monasteries, a process that could take months or even years for a single Bible. Gutenberg knew that if he could find a way to make books quickly and cheaply, he'd be onto a winner. Gutenberg wasn't working in a vacuum. He was a brilliant connector of ideas. He didn't invent printing, paper, or even movable type. We know those came from Asia. What he did was pull together several existing technologies and add his own ingenious twist to create a whole new system. He knew about the screw presses used by winemakers to crush grapes and by paper makers to squeeze water out of pulp. He thought, what if you could adapt that powerful pressing action to push paper evenly onto inked type? This was a key piece of the puzzle, providing the firm, consistent pressure needed for a clear print. His real genius, however, lay in the type itself. The clay or even bronze type used in Asia worked, but Gutenberg, with his metalworking background, wanted something better. He developed a special alloy of lead, tin, and antimony. This mixture was perfect because it melted at a low temperature, making it easy to cast, but was hard enough to withstand thousands of impressions without wearing down. He also perfected a handheld mold that allowed him to cast new letters quickly and with incredible precision. Every E had to be exactly the same height as every T so the finished page would be perfectly flat. So Gutenberg combined 4 key elements: media group, movable metal type letters arranged for printing, metallic type pieces on a wooden tray at stockat at distribute _ equally, movable metal type made from his special alloy, a new type of oil-based ink that would stick to the metal, the powerful screw press adapted from winemaking, and of course paper. It was the combination of these things, a complete manufacturing system, that was his true invention. Around 1450, his workshop was up and running, and he set about his most ambitious project, printing a Bible. This wasn't just any book, it was the ultimate test of his new technology, a massive 2-volume work that would prove the power and quality of his press. So, how did Gutenberg's press actually work? It was a hands-on, mucky, and brilliant process that required a team of skilled workers. First up, you needed the letters, which were called sorts. These were kept in big, shallow wooden trays called type cases. The capital letters were in the upper case and the small letters in the lower case, a term we still use today. A compositor, or typesetter, would stand in front of these cases with a little handheld tray called a composing stick. Reading from a manuscript, they would pick out the letters one by one and arrange them in the stick to form words and lines of text, all in reverse, like looking in a mirror. Once the composing stick was full, the lines of type were carefully transferred to a larger tray called a galley. This process was repeated over and over until you had enough lines to make a full page. The compositor had to be incredibly careful, adding tiny slivers of blank metal to make sure every line was exactly the same length, a process called justification. When the whole page of type was assembled, it was locked tightly into a metal frame called a chase. This heavy, solid block of metal and text was now ready for the press. It was a painstaking job that required a keen eye and a steady hand. Next, it was time for the ink. Gutenberg's special oil-based ink was thick and sticky, a bit like varnish. It was applied to the type using ink balls, which were basically leather pads stuffed with horsehair or wool and attached to handles. A printer would dip these balls into the ink, work them together to get an even coating, and then dab them carefully all over the surface of the type. You had to get just the right amount of ink. Too little, and the print would be faint. Too much, and it would smudge and blur the letters. It was a messy, smelly job, but absolutely vital for a crisp, clear result. Finally, the moment of truth. The inked-up frame of type was slid into the flatbed of the press. A sheet of dampened paper was carefully laid on top. Then, the pressman would pull a large wooden handle. This turned a giant screw, which pushed down a heavy flat wooden plate called a platen. The platen pressed the paper down onto the inked type with immense, even pressure. The handle was released, the platen lifted, and the bed was slid back out. The printer would then peel back the paper to reveal a freshly printed page. They could then re-ink the type and print another copy again and again, producing hundreds of pages a day. Before Gutenberg, a book was a luxury item, something only the very rich or the church could afford. But his press changed everything, and it changed it fast. Suddenly, you could produce books hundreds of times faster than a scribe could copy them by hand. This meant books became cheaper, much cheaper. For the first time, they were accessible not just to nobles and bishops, but to merchants, lawyers, doctors, and students. This sudden availability of written material created a thirst for knowledge, and just as importantly, a reason for more people to learn how to read. Literacy rates began to climb across Europe. The impact on religion was earth-shattering. The first major book Gutenberg printed was the Bible, and for centuries the church had controlled access to the Holy Scriptures. Priests interpreted the Latin text for the people. But the printing press broke that monopoly. Reformers like Martin Luther, who in 1517 famously nailed his 95 Theses to a church door, used the press as their most powerful weapon. His ideas, printed in cheap pamphlets and translated into German, spread like wildfire across the continent. People could now read the Bible for themselves in their own language and make up their own minds. The Protestant Reformation simply could not have happened without the printing press. Printing also had a profound effect on language. Before the press, there were countless local dialects. A person from one part of Germany might struggle to understand someone from another, but printers had to choose one version of a language to print in, to sell to the widest possible audience. Over time, the dialects used by printers in major cities like London, Paris, and Wittenberg became the standard versions of English, French, and German. Spelling and grammar became fixed. The printing press didn't just reproduce languages, it helped to shape and standardize them into the national languages we know today. And then there was science. The scientific revolution was built on the free and rapid exchange of ideas, and the printing press was its engine. Astronomers like Copernicus could publish their radical theories about the solar system, and scientists across Europe could read, debate, and build upon his work. Anatomical textbooks with detailed, accurate illustrations could be printed and distributed to medical students everywhere, replacing old, inaccurate, hand-copied diagrams. Knowledge was no longer locked away in isolated monasteries. It was shared, checked, challenged, and expanded at a speed that was previously unimaginable. The world was becoming a more connected and more knowledgeable place. While Gutenberg's invention was sparking a revolution across Europe, the story of printing in other parts of the world was, well, very different. The technology didn't spread everywhere at the same speed or in the same way. In the vast and powerful Islamic world, which stretched from Spain to India, there was a strong and beautiful tradition of calligraphy. The handwritten Quran was considered a sacred art form, and there was deep cultural resistance to the idea of printing it with a cold, mechanical press. For religious texts, the artistry of the human hand was seen as essential, a form of devotion that a machine just could not replicate. This meant that the adoption of the printing press in the Ottoman Empire and other Muslim regions was much slower. The first press using Arabic script was not established in Istanbul until 1727, nearly 300 years after Gutenberg. Even then, it was initially restricted to printing non-religious materials like dictionaries, history books, and scientific works. It took a long time for printed books to become common, and the rich tradition of handwritten manuscripts continued for centuries. This wasn't a failure to adopt technology, but a conscious cultural choice that valued artistry and tradition over mass production for certain important texts. Meanwhile, in India, the story was different again. The first printing press arrived in Goa in 1556, brought by Portuguese missionaries. Their goal was to print religious texts to help spread Christianity. The challenge they faced was immense. India is a land of many languages, and crucially, many different scripts. Each script, like Devanagari for Hindi or the Tamil script, has a huge number of characters, including combinations of consonants and vowels. This made creating a full set of movable type far more complicated and expensive than for the simple Latin alphabet with its 26 letters. It was a huge technical hurdle to overcome. Despite these challenges, printing did slowly take root. Early Indian printers, often working with European collaborators, began to create type for local languages. They printed grammars, dictionaries, and eventually literature and newspapers. This process helped to standardize scripts and promote regional languages, much as it had in Europe. But the sheer diversity of scripts meant that the path of printing in India was a complex patchwork, with different regions and languages moving at their own pace. The journey from a single Latin-based press in Goa to a thriving multilingual printing industry across the subcontinent was a long and fascinating one. For about 350 years after Gutenberg, the basic design of the printing press didn't really change all that much. It was still a wooden, hand-powered machine that relied on human muscle. But then, around the year 1800, the Industrial Revolution came along and, well, it turned the world of printing upside down. The first major change was in materials. A man named Earl Stanhope built a press made almost entirely of cast iron. It was incredibly strong and durable, and because of its clever system of levers, it required less effort from the printer, but could apply much more pressure. This meant you could print bigger pages with a clearer impression. It was a huge step forward in both quality and power, but honestly, the real revolution was in speed. The demand for printed material, especially newspapers, was exploding. Hand presses were just too slow. In 1814, Friedrich Koenig, a German inventor working in London, unveiled a radical new machine for the Times newspaper. His press was powered by a steam engine. It used cylinders to press the paper against the type, rather than the flat platen of the old presses. This machine was a monster, clanking and hissing, but it could print over 1,000 sheets per hour, about 4 times faster than the best hand press. For the first time, news could be truly current, printed and distributed to thousands of people in a single morning. The thirst for speed didn't stop there. In the 1840s, the American inventor Richard Hoe developed the rotary press. Instead of putting the type on a flatbed, he figured out how to attach it to a spinning central cylinder. Huge rolls of paper were fed into the machine, which printed on both sides at once before cutting the sheets. These machines were giants, filling entire rooms, and they were astonishingly fast. By the late 19th century, a big rotary press could churn out tens of thousands of newspapers per hour. This was mass production on an industrial scale, making newspapers and cheap books available to everyone. But there was still a bottleneck: typesetting. Every single letter was still being set by hand, just as it was in Gutenberg's day. It was slow, laborious work. The breakthrough came in the 1880s with the invention of typesetting machines like the linotype. A linotype operator would sit at a keyboard, a bit like a typewriter. As they typed, the machine would assemble a line of brass letter molds, automatically justify it, and then cast it as a single solid slug of hot metal. It was an incredibly complex and brilliant piece of engineering. A good operator could set type many times faster than a hand compositor, finally making the whole printing process, from start to finish, fully mechanized. From the very beginning, people wanted to include pictures in their printed books. The earliest method was to use a woodcut. This worked just like the woodblock printing from China. An artist would carve an image into a block of wood, and this block could be locked into the frame alongside the metal type and printed in one go. The results could be beautiful, but woodcuts were often a bit chunky and lacked fine detail. For more detailed illustrations, printers used a different technique called engraving, where the image was cut into a metal plate, usually copper. The lines were filled with ink, and the plate was pressed onto the paper, creating a much finer and more elegant picture. The big problem with engraving was that it was a separate process. You had to print the text pages and the picture pages on different presses, and then bind them together, which was expensive and time-consuming. A major breakthrough came in 1796, when a German author and actor named Alois Sennefelder invented lithography. His method was based on a simple chemical principle: grease and water don't mix. He would draw his image on a smooth, flat block of limestone with a greasy crayon. He'd then wet the stone. The water would be repelled by the greasy drawing, but would soak into the rest of the stone. When he rolled oily ink over it, the ink would stick to the drawing but not to the wet parts. This allowed for much freer, more artistic illustrations. Lithography was fantastic for art prints and posters, but the holy grail was printing photographs. Early photos couldn't be printed in a book alongside text. You had to print the photo separately and paste it in. The solution, developed in the 1880s, was the halftone process. This was a clever trick that broke a photograph down into a pattern of tiny black dots of different sizes. When viewed from a distance, our eyes blend these dots together to see a continuous image with shades of gray. A photograph was rephotographed through a fine screen to create the dot pattern, which was then etched onto a metal plate. This plate could be used on a regular printing press, finally allowing photos to be mass-produced in newspapers, magazines, and books. The 20th century saw another huge leap with the invention of offset printing, which built on the principles of lithography. Instead of printing directly from the stone or metal plate onto the paper, the inked image was first transferred, or offset, onto a rubber blanket cylinder. This rubber cylinder then pressed the image onto the paper. This indirect method had huge advantages. It produced a much sharper, cleaner image, and the flexible rubber blanket could print on all sorts of surfaces, not just smooth paper. Offset lithography became the dominant printing technology for most of the 20th century, perfect for high-volume, high-quality color work like magazines, brochures, and art books. For most of the 20th century, printing meant big, noisy machines, hot molten lead, and greasy ink. But in the second half of the century, a new force began to emerge that would change everything: the computer. The first step away from metal type was phototypesetting, which became popular in the 1960s and 70s. This system used a photographic process to create text. Letters were stored as negatives on a film strip. A bright light would flash through the chosen character, projecting it onto photosensitive paper or film, which was then developed to create the page layout. It was cleaner, quieter, and much faster than the old hot metal linotype machines. This was a big change, but the real revolution was just around the corner: desktop publishing. In the mid-1980s, three things came together to put the power of a print shop onto a desk. First was the Apple Macintosh computer with its user-friendly graphical interface. Second was page layout software like Aldus PageMaker, which let you see what you were designing on the screen. And third was the laser printer, which could translate that digital design into a high-quality printed page. Suddenly, anyone could design and print professional-looking documents, from newsletters to flyers, without needing a team of specialized typesetters and printers. This new digital workflow completely transformed the professional printing industry. The old process of physically cutting and pasting text and images onto a board to be photographed was replaced by computer-to-plate or CTP technology. Designers could create a complete page on their computer and send the digital file directly to a machine that would etch the printing plate. This eliminated several steps, saving time and money, and dramatically improving the quality and accuracy of the final print. The clanking, messy world of hot metal was fading into history, replaced by the quiet hum of servers and the precise glow of lasers. The move to digital also brought about a new kind of printing altogether: digital printing. Unlike offset printing, which uses plates and is efficient for large runs, digital printers like high-end laser and inkjet machines print directly from a digital file. This means there are no setup costs for plates. While it might be more expensive per page for a huge job, it's perfect for small print runs. Need just 50 copies of a report or 100 wedding invitations? Digital printing is the perfect solution. It opened up a whole new world of possibilities for short-run, personalized, and quick turnaround printing jobs. So where are we today on this epic journey? The world of printing in 2025 is a fascinating mix of the old and the new. For big industrial-scale jobs, offset printing is still the king. If you want to print 100,000 copies of a magazine, a million flyers, or a national newspaper, the speed and cost-effectiveness of a massive offset press is unbeatable. These modern presses are technological marvels, highly automated and computer-controlled, churning out incredibly high-quality color printing at breathtaking speeds. They are the direct descendants of Koenig's steam press, just infinitely more sophisticated. But for a huge and growing number of jobs, digital printing is the answer. The quality of digital presses has become so good that it can be hard to tell the difference from offset. This has powered a massive boom in online printing services. Anyone with a computer can now design a business card, a family photo book, or a poster, upload the file to a website, and have the finished product delivered to their door a few days later. This convenience and accessibility has put professional quality printing into the hands of everyone, from small businesses to individuals planning a party. One of the most exciting developments is print on demand, or POD. This technology, powered by high-speed digital presses, allows books to be printed one at a time, to order. This is a complete game changer for authors and publishers. In the past, you had to print thousands of copies of a book and hope they would sell. Now, a book can exist as a digital file, and a physical copy is only created when someone actually buys one. This eliminates the financial risk of large print runs, and means that books need never go out of print. A book published 20 years ago can be just as available as one published yesterday. From a simple seal pressed into clay to a global network of online printers that can deliver a single book to your doorstep, the journey of printing has been incredible. It has democratized knowledge, fueled revolutions, and shaped the very way we communicate. Every time you read a book, a magazine, or even the label on a jar, you're experiencing the legacy of Bisheng, Gutenberg, and countless other innovators who work to find better ways to share ideas. The technology has changed beyond all recognition, but the fundamental goal remains the same: to take one idea and make it many, and that surely is a kind of magic.